Okay, hey, we're on to lesson 9. And you know what? Lesson nine's objective is means that today is going to feel like a success. Today's going to feel like a win because the objective for lesson 9 in module 3 is to add fractions, making like units numerically. Now, the funny thing for us is we've already been doing that. Now, in the past, remember, we had done a lot of boxes and we had to make both boxes match. If this was in halves and this was in thirds, then we put this in thirds and we put this in halves, right? So that way we would have sixths and sixths. That's what we had done in the past lessons. But we're going to take some steps. We're going to move on up to the next step here so that we understand that fractions don't always have to go. My steps got too big. But fractions, I need to put a step there. Fractions don't always have to, you don't have to draw out a picture for every single one of your steps. So let's move ourselves on up. I am going to show you a couple of different ways to do this. I'm going to show you a couple tricks. So let's start with this one that I'm kind of showing you right now. 1/2 plus 2/3. Now, that would be this one, right? Originally 1/2 plus 2/3. That would have been 1, 2, 3 plus 1, 2, 3, 4, right? But I want to show you a couple of different ways that you can do this, okay? First thing that you can do is you can understand that in order to make like units, you're basically multiplying, you can multiply these two things by each other, which means I'm going to show you what's called the butterfly method. And I'm going to use, well, I guess I'll just use this yellow highlighter. No, I'll use my pink and green highlighter. There we go. All right, so I'm going to use my highlighters to show you why it's called butterfly method. Okay, so step 1 is we're trying to make new, we always are making new fractions, right? You cannot add or subtract fractions unless they are like units, which means they have the same denominator, right? So step 1 is I'm always going to draw this out. Well, when I'm doing my butterfly, in order to get the denominator, all I'm really doing is multiplying the bottoms, right? So I'm taking my bottoms, multiplying them together, and that's how I'm getting my new numerator. Because 2 times 3 is 6. I know that 2 and 3 will both fit into 6, so that's my new numerator. Denominator, forgive me. That's my new denominator. But that's not the butterfly method, okay? The butterfly method goes like this. These two get multiplied together. These two get multiplied together, and that plus sign gets brought down. Do you see my butterfly on there? So the butterfly method says that I'm going to do 3 times 1 to get this numerator, and I'm going to do 2 times 2 to get this numerator, which means 3 times 1 is 3, 2 times 2 is 4. So I just made a butterfly. I created new fractions. I replaced these fractions with these fractions because I did 2 times 3 to get my new denominator. Whatever I do to the bottom, I do to the top. I did multiply 2 times 3 to get 6. So 3 times 1 has to give me this 3. 2 times 2, because I multiplied 3 times 2 to get 6. 2 times 2 is 4. So that's the butterfly method. That's how you can, if you can remember the butterfly method, you can always add fractions, which gives me the denominator of 6. 3 plus 4, whoops, I almost put 17. 3 plus 4 is 7. Now, when you look at that, you should go, wait a minute, 7/6, is that right? My head is heavy, right? That's an improper fraction. The head is heavier than the base. So I know that really what I have is 6/6 plus another 1/6, and 6/6 is really 1 whole and 1/6. Okay, that's the butterfly method. You can also look at a problem like this. That was my number 1 example. Here's my number 2 example. You can look at a problem something like, smaller, 5/9 plus 5/6. Now, don't for a minute get confused and think that those are like units. Numerators are not the units. Denominators are the units, right? So you have to have the same denominator. Now, I could do the butterfly. I could do 5 times 9. I could do 9 times 6 to get my numerator. But you know what? If I do 9 times 6, I'm going to get a very big number, right? I'm going to have 56. And chances are, if I have a denominator of 56, I'm probably going to have to reduce. I'm going to have to find an equivalent fraction that's smaller than that. So instead, when you have big numbers, right, what I want you to do is go ahead and count by multiples of whatever whatever one of the numbers are. So I'm going to go 9. I'm counting by multiples of 9, right? So I'm going 9, 18, 27, 36. Notice when you're counting by nines that you're just going 1, 2, 3, 4, and then 8, 7, 6, 5, right? So I'm going to stop because when I got to 36, that is also a multiple of 6. I know that I skipped 18. 6 will also fit into 18, right? That's even smaller. So now I know that I want my new denominators to be 18. That's the smallest number that both 9 and 6 will fit into. That's called a lowest common multiple. Because I know that 9 times 2 is 18, but I also know that 6 times 3 is 18. Right? So then I'm going to do what we've practiced doing several times. How do I turn a 9 into an 18? I have to times it by 2. And whatever I did to the 9, which is the denominator, I do to the numerator. Whatever I do to the bottom, I do to the top. So 5 times 2 is my new numerator that's going to be down here. So 5 times 2 is 10. What did I do to 6 to turn it into 18? I had to multiply it by 3. Whatever I do to the bottom, I do to the top. So 5 times 3 is 15. Now, I've seen people get confused here, but I really want you to see how this both times had to be times 3. Whatever I did to the 6 to get the 18, that's what I had to do to the 5 to get the 15. I cannot switch it up. This definitely has to stay times 2 times 2 or times 3 times 3. Now, all I have to do is add 10 plus 15, which is 25 over 18. Again, its head is heavy, right? What I really have here is 18 18s plus 18, 19, 20, 21, 22, 23, 24, 25, 7 18s, which really means I have one whole and 7 18s. All right, I'm going to show you one more example. This time we're going to have 3 numbers. So here's my example number 3. This is my final example for your notes. This one is 2/3 plus 1/4 plus 1/2. Now, just like we have been doing all along, we have to definitely get new denominators, right? We have to get like units. So I'm going to go ahead and bring my plus signs down. Now my job is to think of the lowest number that all 3 of these numbers can go into. So let's start by counting with the bigger number. 4, 8. Well, 2 will go into 8, but 3 will not go into 8. 4, 8, 12. Ooh, 2 goes into 12, 3 goes into 12, and 4 goes into 12. So 12 is my lowest common multiple, right? 12 is my lowest common multiple. That means I can make equivalent fractions. I can make fractions that are equal to 1/2, 1/4, and 2/3. Equivalent fractions that are all in 12ths. So let's make an equivalent fraction for my 3. Well, I have to multiply a 3 by 4 in order to get 12. So whatever I do to this, see, all I'm doing right here is this fraction, right? So, this fraction right here is turning into this fraction right here. So I've already got the numerator. I need to get the denominator. 3 multiplied by 4, so 2 is multiplying by 4. 2 times 4 is 8. This one I'm doing 1/4 is going to turn into something close. Well, 4 to turn into 12 has to multiply by 3. So I have whatever I do to the bottom, I do to the top. 1 times 3 is 3. So 1/4 is the same as 3/12. Those are those equivalent fractions that we've been practicing. Now I have to do a half. You could take all the time to figure that out, but you might already know what half of 12 is. Do you already know that half of 12 is 6? In other words, I had to multiply 2 by 6 in order to get that 12. So up here, I'm going to multiply 1 times, this should be a 6. 1 times 6 to get that 6. So remember, I'm just making a new numerator when I do all that math. Now I can add them together. 6, 7, 8, 9 plus 8 is, 9 plus 8 is, my brain's going blank, is 17 over 12. This is an improper fraction. I can't leave it that way. That's really 1 whole, or 12 twelfths, and 5 twelfths. Can I reduce 5 twelfths? No, because this is divisible by 2, but 5 is prime. You can't divide 5 in any kind of way. So that's the end. In your problem set, we're on page 31. You don't have to draw anything. You just have to make like units. So for every single one of these, you should have something that looks like this, because every single time you're making you have to make like units, right? I'm going to give you a hint. I'm going to show you which ones are good to butterfly. So I'm not going to solve any one of these for you, but I will show you which ones are good for butterflying. Let's see, 7 and 4. This one's good for butterfly. This one's good for butterfly. Those are the only two on that page that are good for butterflies. What I'm saying is these ones you can use this method that I showed you like this. Those are the only ones you can use this method. The rest of them, you need a lowest common multiple, meaning the smallest number that a 7 and an 8 will go into. So I would just count, actually you could probably butterfly this one. But all the other ones that you can't butterfly, you're looking for the lowest common multiple. Okay? Go ahead and do page 31 and 32. Get back to me in our group when it's your time.